Hello, today I will be discussing the topic called the segment tree, and it is part of a broader concept where we perform range queries. What do you mean by a range query? So, given an array, first give me 1 second, let me reduce the volume of this shit. Yeah, okay. So, suppose I'm given an array and I have to perform some sort of operations on it, like I can update an element, right? I can replace an element. Those are the same thing. I can update an element, I can add some stuff to an element, I can subtract some stuff from an element, and once I'm done processing whatever the hell this is, then I have to calculate something for a given particular range. And yeah, these come in two types. So we have static queries and we have dynamic queries. And for the static ones, we are just given an array and we are supposed to calculate some stuff for given L to R range, right? But for a dynamic query, what we have to do is that we also have to update and add or like remove some stuff, and then we can calculate some stuff for the ranges L to R, right? So with this information in mind, the one or two data structures like that we use for solving these types of problems, the first and the most versatile one would be the segment tree, and personal favorite and the topic of discussion for this video. The second one is called a Fenwick tree, and this is very useful for queries that are like of not reversible nature, I would say. Not reversible, they are, this is good for the queries that are of an invertible function, if that makes any sense. uh, Let me just give you an example only. Okay, so this is good for plus, this is good for XOR, not good for minus actually, and not good for min max also. Okay, I don't think there is even a minus operation that we can even perform here. Okay, not good for percent as well, and multiple other things that a Fenwick tree is not good for. But for the things that it is good for, it is really good for them. So I have some benchmarks that I will show later, but yeah, this is the gist of it. Okay, the third one would be a sparse table, but even I have not studied it. I don't know what the fuck is the use of it. But the segment tree being the most versatile one, we will study two types of it, and I will like give you a resource for the first recursive type. Okay, just watch Code Story with Mike. The guy taught it really well. I'm not gonna waste time here for that. I will perform the iterative version. Okay, iterative version is so good for this, like it outperforms the recursive version, like version so fucking hard. It's like for the I will give you some benchmarks. For iterative it was like 0.05, whereas for recursive it was like 2 seconds. Okay, so there's a major gap between iterative and recursive. Okay, so I will be discussing on the iterative version, which is not really available properly anywhere else that I like looked for. So uh, yeah, I wanted to record a video for it, I wanted to revise it, वगैरह. And one place that I found some resources for it was like a Code Forces blog. Okay, I will link it in description. Okay, so that was the introduction. Okay, so I will be performing something called a range minimum query. Okay, so already something that is not a plus or like a solve, which is very common type of query and can be performed also by a Fenwick tree, and in fact better by a Fenwick tree. So I won't be going there, but just know that anywhere I use a min here. 1 second. Okay, yeah, refresh it, it's back. Anywhere I use a min here, you can just replace it with your whatever function. So this could be plus, this could be XOR, anything you want, max. Okay, anything you want, and this tree will work just fine. Okay, so with that, all that information in mind, let me start by telling you what a segment tree is. Okay, so given an array, right, we start by pre-calculating stuff for like parts of it, है ना? And then we start to combine results of those parts and ultimately get our whatever the function is for the full array, right? Let me take an example. So I will take in 2 minus 3 1 4 5. Okay, so for this one, what I do is I find a minimum for these two first. So minus 3, I find a minimum for these, this is 1, and I find a minimum for this, which is just 5. Okay, now I start combining. So this would be just minus 3, and for this one just gives 5, and again for these I combine, so this is minus 3. Okay, एंड विद दिस यू कैन सी अ काइंड ऑफ ट्री स्ट्रक्चर फॉर्मिंग. मैंने इसको थोड़ा सा उल्टा बनाया है, डोंट माइंड दैट, बट जनरली इसको लाइक ऐसे ऊपर बनते हुए दिखाते हैं. एंड दिस इज द प्रॉपर डायग्राम फॉर द रिकर्सिव वन एज वेल इफ यू लुक फॉर इट. ओके, नाउ अगर मुझे कोई सी भी क्वेरी परफॉर्म करनी होती है तो मैं इस ट्री में नीचे जाता हूँ और लाइक उस पर्टिकुलर रेंज पे देखता हूँ कि अगर मेरे को फुल कवरेज मिल रहा है तो दैट इज़ माय आंसर. अदरवाइज आई जस्ट डू सम अदर ऑपरेशंस. लाइक अगर मेरा ये मेरी रेंज है और अगर मेरी ट्री वाली रेंज बाहर जा रही है तो आई जस्ट ट्राई टू श्रिंक दैट रेंज. इफ़ अगर मेरी पूरी रेंज है तो आई जस्ट रिटर्न आंसर फॉर दैट रेंज वगैरह वगैरह. अगर स्लाइट सा ओवरलैप है तो मैं इस वाली रेंज को डिस्कार्ड करने की कोशिश करता हूँ वगैरह वगैरह. So again, that part is for the recursive tree, and that is very nicely covered by code story with Mike. So won't be going there. I will be covering the iterative version. Okay, so now the difference between iterative and recursive versions is that first of all, iterative is slightly more rigid in its structure, right? So if you know, for recursive you start by defining a tree of size 4n. Okay, but for iterative you only need 2n का space, है ना. तो पहला बेनिफिट तो ये हो गया. एंड ऑब्वियसली रिकर्सिव ओवरहेड वगैरह कुछ नहीं आता, तो दैट्स ऑल्सो अ बेनिफिट. बट वी स्टार्ट बाय डिफाइनिंग एन एरे ऑफ साइज 2n. I will tell you like why. Let me pick up an example from above. So I will be discussing segment trees using these two examples. Why is it not getting copied? Copy हो जा भाई. Okay, हो गया. Yes. So this is the start of my array, and I will tell you how and why I made it this way. But let's start by the code that I will be using to build it. Okay, तो मैंने क्या बोला था कि मैं तुमको एक 2n का साइज 2n साइज का array डिफाइन करने को बोल रहा हूँ मैं, है ना. And why I did that is that the first like the starting from the end, these elements will only cover your array itself. Okay, so this part of size n will be your array only. Okay, and this leftover part of size n, this will represent these kind of segments that we have divided our array into. Okay, so every node here can be seen like as a parent of these children nodes, and every node here will cover multiple nodes here. Okay, and similarly if we are way down the line over here, so this node will start to cover multiple of these nodes. Okay, so this kind of forms like a tree structure only. So I have an array here. Okay, so I combine these two to form a node above, and combine these two to form a node above, and these two to form a node above. So what these nodes are like idhar wale nodes in this tree, and these root nodes are represented by this particular part here. Okay, uh, there is a very long proof for why these nodes are also of size n, and this is of size n, so we need a size of 2n. I won't go there, but you can just take my word for it कि यहाँ पे size n लगता है, and यहाँ पे भी size n लगता है, and no one will ask you any questions about it. Okay, so as I said कि मैंने क्या बोला, I will define an array, and I will divide this array into two parts. This is the parent nodes, and this will be my root nodes. Okay, now यहाँ तक का मेरा होगा n कवरेज, मतलब लेंथ ऑफ एरे, है ना. तो लेंथ ऑफ ARR. तो अब तुम ही बता दो कि ये ट्री कैसे बनानी है. इतना पार्ट तो बता ही सकते हो. तो फॉर आई इन रेंज n ट्री, ये वाला एरे जो है इसको मैं ट्री बोल दे रहा हूँ, है ना. ट्री ऑफ i प्लस n इक्वल्स टू एरे ऑफ i. सिंपल, है ना. तो यहीं पे यहाँ पे मैंने यही करा. तो ये जो देख रहे हो ना, ये बेसिकली ओरिजिनल एरे ही है जिसको मेरे को लिखने में ऊपर आलस आ रहा था. तो जस्ट सुन लो यहाँ पे चुपचाप से. दिस इज माई ओरिजिनल एरे. Okay, and I built this entire structure using first of all this loop, and the second loop I will tell you about what the hell are we doing here. So now we start to fill these child nodes, right? Let me get some water. Okay, so मेरा टारगेट क्या है कि मुझे इन चाइल्ड नोड्स को भरना है ना. तो एज आई सेड कि वी विल स्टार्ट बाय कवरिंग 2 nodes फॉर एवरी चाइल्ड नोड, है ना. So this will cover this particular one, and this will cover this particular one range. Okay, and this will cover this particular range. Okay, so let me demonstrate it here only. Every node in this every ith node in this tree will have left and right children, है ना? Left will be 2i and right will be 2i plus 1. This is very much akin to the recursive one. Okay, so just keep that in mind. Okay, this is just kind of actually, in fact, not even gonna lie, you can, even for the recursive version, you can make the tree iteratively only. Okay, so for you can keep the query and update as recursive functions, but even there this type of tree will hold itself legitimately. Okay, so there is no problem with that. Now as I said, it is very much akin to that version. So for every node I, you have its left child as 2i and right child as 2i plus 1. This is very like common knowledge for binary tree, so nothing to explain here. Now 13th node will cover these two nodes. Okay, so minimum of 2i and 2i plus 1. Okay, similarly 12 will cover 24 and 25, so again 2i and 2i plus 1. Okay, sixth will cover 12 and 13, so minimum of 2i and 2i plus 1. This will give you 12, this will give you 13, and you have this particular range. Okay, so as you can see, sixth node here, it starts to cover like four nodes of our original array, right? So this is like being in the third level from the root. Okay, so here we covered like one node, है ना? Here we like combined them or consolidated them into two nodes, and here we consolidated that information into four, like of about four nodes. Okay, so we are on like level 3 from sixth point onwards. Okay, so यहाँ से आगे बढ़ते हैं. This is like how I was making this tree. So for I should write this like pretty nicely, है ना? तो start by defining root nodes, है ना? And for that you use this loop. And now my next step would be to combine info of children into parents. But what I mean by this is that function of uh, tree of I equals to function of tree of 2i plus 2i and tree of 2i plus 1. And by function what I mean here is min, sum, max, xor, these kind of functions. Okay, uh, okay, so for I in range n minus 1 comma minus 1 comma minus 1, what I do is that again this same thing only. So tree of I equals to f of यहाँ पे मैं मिनिमम लिख रहा हूँ. ओके, बिकॉज आई एम मेकिंग अ मिनिमम ट्री. सो मिनिमम ऑफ ट्री ऑफ 2i comma tree of 2i plus 1. I'm trying to keep the code as close to the working version as possible. Okay, so like yeah, I'm trying to keep the syntax and everything in order. So we have these two loops, and these two will create the tree. Okay, so create the tree. Now what I want to do is that I want to start updating this tree. I don't want to like start. Okay, actually, you know what, fuck it, let's start with the harder part first. I want to query this tree. Okay, so let me copy it again. Did not get copied. Yep. All right, now let me start querying whatever the fuck you want in this tree. Okay, so think of it as a static query, and once we learn the update function, we will be able to do dynamic queries as well. Okay, nothing to write after the arrow here. Okay, तो मैंने मुझसे बोल दिया कि मुझे ना तुम एरे में, ओरिजिनल एरे में लेफ्ट मेरा मान लो कि मेरे को देख के रखा है 0 और राइट मेरे को देख के रखा है 10, नॉट 10, कीप इट सिंपल फॉर वाइल, मेरे को 5 दे के रखा है ना। तो मुझे पहले इसका सम निकाल के बता दो, मतलब इस रेंज में मुझे मिनिमम निकाल के बता दो, है ना। तो what I will start by is that first of all, obviously we will query the segment tree. Now we won't be querying the original array. So first of all, start converting this into the segment tree के indices. So add n here. N is the length of array, which is given by like 13. So 13, not 13, 14 से start करेंगे. So plus 14. So 14 and 19. This is the range that I will be starting with in the original segment tree. Okay. 14 से लेकर 19 तक. This is what I will be querying. Also let me copy paste. Fuck. And also here, because we will be using a lot of this and I don't want to paste it later. Alright. Now the thing is, I want you to notice some stuff here before I start querying. Okay, as you can see, for every parent node, its range starts with an even number and ends with an odd number. Okay, so what this describes is a perfect range. And my statement, the statement that I will make in front of you right now is that, okay, if I have a range that starts with even comma odd, any kind of range, then I will be able to find nodes in the like parent nodes perfectly for it, so that there will be like मैं पहले perfect condition बता देता हूँ. Perfect condition मतलब मान लो मेरे को देखो ऐसे पूरे के पूरे nodes मिल गए मेरे को, है ना. इट्स नॉट लाइक कि मेरे को 12 से लेके 20 तक का निकालना है तो मेरे को आधे आधे नोड्स मिल रहे हैं ना. आई कैन गारंटी कि अगर मेरे को एक ऑड दे के रखा है और एक इवन दे के रखा है और एक ऑड दे के रखा है, तो आई विल बी एबल टू कवर दिस रेंज परफेक्टली. एम आई रॉन्ग? ट्राई टू प्रूव मी रॉन्ग. ओके, मेरे को बोल दिया 12 से लेके 19 तक का निकालो, देखो मेरे को मिल गई परफेक्ट रेंज. मेरे को बोल दिया 10 से लेके 25 तक निकाल दो, ये रही परफेक्ट रेंज, है ना. मेरे को बोल दिया 6 से लेके 18 तक निकाल दो, है ना. तो देख रहे हो यहाँ पे प्रॉपर कवरेज नहीं मिल रहा मेरे को, है ना, क्योंकि यहाँ पे भी इवन था, यहाँ पे भी इवन था. तो मेरा हाइपोथेसिस ये है, मेरा हाइपोथेसिस नहीं, मेरा स्टेटमेंट ये है कि अगर मेरे को एक परफेक्ट रेंज है, स्टेटमेंट इफ आई हैव an ideal range that is even, starts with an even number and ends in an odd number, then I can fully overlap it in my tree. Okay, that makes sense, है ना. So with this statement in mind, what my approach here will be that I will try to convert any given range L to R into a perfect range. Okay, and how do I do that? Okay, so suppose मेरे को देके रखा है L even देके रखा है और ये मेरे को ऑड देके रखा है, तो मेरे को तो कोई ज़रूरत ही नहीं है करने की, है ना. मैं चुपचाप से जाऊँगा, इसको क्वेरी भी नहीं करूँगा, मैं जाऊँगा इसके रूट नोड्स पे पहले, है ना. वरना ऐसे क्वेरी करने बैठ गए तो तुम इवन से ऑड में इधर ही करने लग जाओगे ना. तो मैं जाऊँगा इसके रूट्स पे कैसे जाऊँगा? इवन बाय टू एंड ऑड बाय टू. क्यों? क्योंकि किसी भी नोड को डिवाइड बाय 2 करके देखो, उसके पेरेंट आ जाएंगे, है ना. 14 का बाप 7 है, 15 का बाप भी 7 है ना. 16, 17 इन दोनों के बाप कितने हैं? ये रहे. तो किसी भी नोड को तुम बाय 2 कर दो तो तुम्हें उसका पेरेंट मिल जाएगा, ठीक है. और मैं बाय 2 क्यों कर रहा हूँ यहाँ पे? क्योंकि मेरे को ना कंसोलिडेटेड इन्फॉर्मेशन का यूज़ करना है, बिकॉज मैंने ऑलरेडी इतनी मेहनत कर ली है कि मैंने हर नोड की इन्फॉर्मेशंस को लाइक एक ग्रुप्स में डिवाइड करके स्टोर करके रखा है. तो मैं क्यों फालतू में इन नोड्स को क्वेरी करूँ अगर मेरे पास ऑलरेडी इनके पेरेंट्स में स्टोर है इन्फॉर्मेशन फॉर लाइक मल्टीपल ऑफ दीज. ओके, सो नाउ बैक टू द टास्क एट हैंड. आई हैव टू क्वेरी फॉर 14 से लेके 19 तक, है ना. तो मैंने क्या बोला कि मेरी इवन से लेके ऑड तक की रेंज होनी चाहिए, है ना. तो 14 तो इवन है, 19 ऑड है, बहुत ही बढ़िया बात है. मेरा स्टेटमेंट क्या था कि मैं 14 से लेके 19 तक की तुमको एक प्रॉपर रेंज, एक मतलब ऐसे पेरेंट नोड्स दे सकता हूँ जो कि इस पूरी रेंज को कवर कर रहे हैं। और कौन कौन से नोड्स होंगे वो? 14/2 दैट इज 7 एंड 19/2 दैट इज 9, है ना। तो मैं गया अपनी पेरेंट्स के पास, कहाँ गया, 7 और 7 से लेके 9 तक, ठीक है। तो मैं 7 से लेके 9 तक गया। अब मैंने बोला कि देखो, ये जो नोट्स हैं ना 7 से लेके 9, इन सब में यू विल फाइंड कंसोलिडेटेड इन्फॉर्मेशन, कंसोलिडेटेड इन्फो फॉर गिवन नोड्स, गिवन n नोड्स इन रेंज L to R, ठीक है। क्या इनमें कंसोलिडेटेड इन्फॉर्मेशन है? देख लो एक बार। 7 किसको कवर कर रहा है? 14 और 15 को, है ना। 18 किसको कवर कर रहा है? 8 किसको कवर कर रहा है? 16 एंड 17 को। एंड 9 किसको कवर कर रहा है? 18 एंड 19 को। सो या इट इज ट्रू, आई डू हैव कंसोलिडेटेड इन्फॉर्मेशन फॉर दीज नोड्स, फॉर दीज नोड इन दिस पर्टिकुलर पार्ट ऑफ माई ट्री. Now I am not done yet. Okay, now I will say कि why do I even bother with these nodes? I can again go further in this line, in this tree, and I would have consolidated information for these nodes as well, right? So again I will check once again, is this even, is this even, or is this odd? So no, this is not even, but yeah, this is odd. Okay, so इफ समथिंग इज नॉट इवन देन दैट मीन्स कि इस पर्टिकुलर रेंज के लिए मेरे पास कुछ भी ऐसा नहीं है विच विल कवर दिस ओनली. वॉट आई मीन बाय दैट इज लाइक, ओके, ट्राई टू लुक वॉट कवर्स 7, राइट. सो 3 covers 7, but 3 also covers 6, which is unwanted. Okay, so I have no other way of covering 7 other than to do it here only, and I have to do it alone. So for any kind of res that I have gotten, res equals to wait, if L percent 2 equal to 1, that is my left range at any points becomes odd, then I have no choice but to deal with that there and then only. So I will have to update my res then and there only by min of array of L comma res. I have to deal with it then and there only. I cannot deal with it in any consolidated part of the array. Okay, and when I do that, I will simply do L plus equals to 1. Why? Because I want to move it towards move it into the range, not outside. I would never do L minus equals to 1. It will expand the range unnecessarily. There's no logic in that. Okay, so I will move this range inside now so that my range covers this particular part. Okay, and now I have dealt with this part, so I don't really need to think about it. Okay, now my even is 8 and my odd, or like my L is 8 and my R is 9, which is odd. So again my statement is that I can find you node that I can find you a range in that upper part of the tree where this information you can find consolidated. Okay, so where is that? ये रही, ये देखो, 4 covers 8 and 9 both. So I don't need to query these two, I can just query this one. And how did I get to this one? L by 2, which is 8, and R by 2, which is which is 4. 8 by 2, which is 4, and R by 2, 9 by 2, which is again 4. Okay, so right now my L equal to R हो गया है ना. तो जैसे मेरा L equal to R हो रहा है, I can just again consider this, and if I go any behind, then my L would be less than, L would be greater than R, and so I don't need to go there. So uh, 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 let me do for one more query so you will understand it better. This time I will directly convert it into tree के indexes. So I'm asking you for the result for 7 से लेके 24. Okay, तो let me start by marking it here only. 17 से लेके 24 तक का. तो is my 17 even? Nope. Is my 24 odd? Nope. So my statement was, if L is odd, then deal with L then and there only, and push L into the range. uh, L into the range. How to convert this into code? If L percent 2 equal to 1, then res equals to min of res comma array of L, oh sorry, not array of L, tree of L, and L plus equals to 1. This will push L into the range, and this is just dealing with it. If you want, you can just use sum here or max here, whatever. Again, you can replace this min with whatever you want and it will work just fine. And if though similar for right here, if r percent 2 equal to 0, then I have to deal with the right one then and there only. So res equals to min of res comma right, array of right, and r minus equals to 1. This will again push the right pointer into the range that we wanted. Okay, so let's start with the query now. I will define my res variable ऊपर यहाँ पे, है ना. तो मेरा जो 17 है, देखो दिस इज क्या बोलते हैं, ऑड, है ना. तो I have to deal with it here only. So res is just -3 right now. Res is initialized with infinity and now I take its min, so it's -3 now. And similarly for this I have to deal with this one and push it into the range. Okay, where is this? Okay, and I have dealt with these two. 3 and -3 and 1 का minimum would be -3 only, so I'm just keeping it here only. काट नहीं रहा हूँ मैं उसको. तो मैंने क्या बोला, मेरी परफेक्ट रेंज आ गई है ना. तो ये मेरा इवन है, लेफ्ट पॉइंटर मेरा इवन है और राइट पॉइंटर मेरा ऑड है. तो आई डोंट नीड टू वर्क फॉर दिस क्वेरी like in this particular part of the tree. I can just go above and I will be able to find a particular part where I have this information consolidated. तो 18 by 2 करो and 23 by 2 करो. 18 by 2 is 9 and 23 by 2 that is 11. And from 9 to 11 I will be finding the consolidated region जहाँ पे मेरी information store है. So I come here 9 to 11 and so the entire information for this, for minimum of this particular part of the tree, I can find it here only. Okay, so 9 10 minus 3, I again try to uh, calculate my what my left and right are, whether they are even or odd. So you can see the problem is here, this should be further inside. So I will take into account the information for 9 here right now only. So my res was -3. Again, 2 is not lesser than -3, so I will just keep it here, keep it the same, and I will cut out this part. Okay, I have done the L plus equals to 1 part here. Okay, now my L is here and my right is here. I will again divide these by 2 because my L is even now and R is odd now. So I can find the information for this somewhere here. That somewhere will be found by L by 2 and R by 2. So 10 by 2 and 11 by 2, this gives us the same thingy, which is 5. So the entire information for this part was supposed to be found out in this part, right? But when I came to this part, I realized that some information I have to deal with then and there only. And then for the rest of the part, that is 20 21 22 20, this part, this entire part was represented by this part of the tree. Okay, and I just divided everything by 2 to get here. Now I have 10 and 11 here, which is like these two nodes, and for this I get the -10 here. So now I will recalculate my res. So res equals to min of whatever the hell I want here, or better yet, let the loop run. My left right now is 5, है ना, or like my right now is also 5. So one of the conditions, anytime I try to like क्या बोलते हैं, कन्वर्ज ऑन टू वन नोड, है ना. तो मैं किसी वैल्यू पे आऊँगा, मान लो 3 पे आ गया, मैं 2 पे आ गया. एज यू नोटिस लाइक मैं किसी भी क्वेरी में एक नोड पे घूम फिर के आ रहा हूँ, मेरा कहीं ना कहीं पे L इक्वल टू R हो ही रहा है ना. तो वेन एवर दिस पर्टिकुलर थिंग हैपन्स, आई नो माई ईदर लाइक L इज ऑड or R is even. One of these conditions will definitely be violated, right? So I can just like not bother with calculating res every time. I can just say okay, at the end as well these will be accepted. So res equals to min of array of L. So this condition will execute and this will update my answer to be -10 finally. Okay, so let me show you the code for it. I will just write it here and then we will try run it again. So we will be doing multiple queries, so it sticks into my mind and yours. Okay, so um, defined by a function, we define a function called query, and we take the input L and R. So I do L plus equals to n and R plus equals to n to convert into tree indexes, and then I run the loop. So while L is less than equal to R, what I do is that first, if L percent 2 equal to 0, not equal to 1, then res equals to min of res comma array of L, and left plus equals to 1, so I push it inside. If R percent 2 equal to 0, then again same thing, and R minus equals to 1. And at the end of it all, I just know, okay, after I'm done with this, I know that my range is perfect now, perfect slash ideal now, and I can find my answer somewhere to the left, not to the left, somewhere above me in the tree. And how do I reach that above? I just do L by 2, L equals to, and R equals to R by 2. Okay, now let us dry run this piece of code again and again so it sticks into our minds. Now I will be executing it for the 16 से लेके 22 वाली query. Okay, so as you can see 16 is perfect, 22 is not, so I will bring it here and my res right now will be 3, है ना. तो कहाँ गया पेन, हाँ. So I have taken this into account, and now 16 to 21 I have a part of the array. So 16 by 2, that is 8, and 21 by 2, that is 10. So this particular part represents my consolidated range, and it is fine, this is not. So again I will push it inside, and right now my answer will become -10. Now for the part 8 and 9, I can again find the consolidated information at node 4. So my L equals to 4 and R equals to 4. So as you can see, my L is even, but my R is not odd. So what I want to do is that I will just do like res equals to min of res comma array of right, and then when I do R minus equals to 1, so my R will be 3 and L will be 4. So this breaks the while loop and I'm out of it, and my rest will just stay -10 because like this holds the -10, which is the smallest part of the array. So I will try to do this one for 21 से लेके 27 now, not even 27, 26 now. Okay, so this part needs to get the fuck out and this part needs to get the fuck out. So my current minimum would be what was this number, I kind of covered it, this was 4 and 4 versus 6, so my current minimum will be 4. Now I want to cover 22 से लेके 25 है ना. 22 से लेके 25 is covered by this particular region. Again you can just do 22 by 2 and 25 by 2 to reach these two nodes. So 11 12, this is not fine at all. Okay, this should be like here and this should be like here. Okay, so my L is not क्या बोलते हैं odd, L is not even, fuck, even odd मैं confuse हो रहा हूँ. So this will execute and I will have to just divide these parts individually now, because my these condition, like this 11 wala block will be covered by L condition and this 12 wala block will be covered by my R condition. So my min will be min of क्या बोलते हैं 4 6 3 comma -7, and obviously -7 wins. Now I need to paste it again for some other queries. 15 से लेके मैंने बोल दिया कि इस बार 27 तक का निकाल के बता दो मेरे को। ऑलराइट, इनफैक्ट भाड़ में जाइए सब कुछ, मेरे को पूरी आरे का ही निकालना है। So my L equals to 14, R equals to 27 right now, and my answer is infinity. 14 is even, which is fine. 27 is odd, which is again fine. So I am telling you that I can find the answer of 14 से लेके 27 in one particular in like consolidated regions, okay, which is given by 14 by 2, which is 7, and 27 by 2, which is 13. So I jump into this part of the array. Now 7 is not fine, 13 is fine. So I will try to like delete this range. So my rest will become -1 right now, and now I will say कि I can find 8 से लेके 13 का answer in another consolidated part of the array. So let me change the color now, and I can find my answer for that in this part. So this will be 4, and 13 by 2 will again give me 6. Okay, so 4 is fine, 6 is not. So I will try to update my answer. So -7 से मेरा -1 से मेरा -7 पे अपडेट हो चुका है, and I will delete this area, and now I am at 4 and 5. Okay, again I can find for 4 and 5 at 2 here, at 2 here. So 4 by 2, that is 2, and 5 by 2, that is 2. So my L equal to R right now. So is this even? Yes. Is this odd? No. So right condition will update my answer to a -10 one. And when I do R minus equals to 1, so my R is less than L, and again I can just exit out of the loop, and my answer is -10. So I think these many queries should like help stick it all into the minds. Now I will try to explain the update thingy. Okay, how do I update stuff in this array? So I have been tasked with updating this value of this -10 to 1. Okay, so just first of all start by updating array like tree of index equal to value, है ना, and now while index is like greater than 1, not greater than 1, greater than equal to 1, what I want to do is that first of all index like by 2, so that I keep jumping to parents every time, and whenever I do index by 2 I will have to like check for the minimum again and again. So tree of index equals to minimum of whatever was previously at that index, and update that like and check it against the new value. Okay, so let me confirm it again. uh, uh, yeah, I don't have to just check for like minimum with the new value. I have to check it for its children's. So 2 index and 2 index plus 1, I have to check it for like uske left and right ports. Okay, very spoke too much, bapre. So yeah, let's play with an update query now. कहाँ गया मेरा डब्बा? अच्छा कलर लिया जाए. ओके, सो 20 को मैंने 1 पे अपडेट कर दिया. 20/2 दैट इज़ 10 पे गया मैं. 10 पे जाके मैंने पूछा कि 20 और 21 में से मिनिमम कहाँ पे मिल गया मेरे को, तो मेरा 1 आ गया यहाँ पे, है ना. नाउ मैंने 10/2 करा 5, है ना. मैंने 5 के बच्चे लाइक दैट इज़ लाइक 10 एंड 11 से पूछा तुम्हारा मिनिमम क्या है, तो इसका मिनिमम 1 हो गया वापस से. और फिर मैं 5/2 करा तो दैट इज़ लाइक 2, एंड मैंने 2 पे जाके मैंने पूछा 4 और 5 में से मिनिमम कौन सा है, तो मेरा आया -3. मैंने 1 पे जाके पूछा 2/2 करा 1, और 1 पे जाके पूछा 2 और 3 में से मिनिमम कौन सा है, तो दैट इज़ जस्ट स्टिल माइनस. वेट, व्हाट द फक है, दिस इज़ नॉट सपोज टू हैपन. I am supposed to update this -10 to 1. Yeah, okay, that is exactly what was supposed to happen. Should, yeah. So this was -3, and it said कि 2 and 3 में से minimum कौन सा है, तो this was -3 and this is also -3, so we will just update that. And yeah, this is how the update query works. It is very simple. So now we are in very much condition to do a lot of CSES questions, at least beginner of range queries. And next time I will be discussing Fenwick tree, so, and also lazy propagation. I have not studied it yet, but I will soon, and I will make a video about it. And this was the best explanation I can provide for the query part of it, and like the iterative segment tree in general. I did not find any kind of this like explanation on any like video form apart from that one code versus vlog. So yeah, hope this comes useful to me in the future, and for anyone that comes across this video. Bye bye.